Good evening to the students of class 12th. Let us solve some numericals based on parallel and series combination of dielectric slabs today in this video. For understanding this theory very clearly, please watch my channel for the chapter number 2, part number 16. So now let us go to the question asked and keep watching the video till end. We shall do numericals on this basis in this particular video. Fine? Okay. So now calculate capacitance of capacitors shown. Fine? Okay. Now let us go to the diagram. You can see A upon 2 written here. It means that this portion is also A upon 2. These are the parallel plates. If this is D and this is D by 2, the other portion is also D upon 2. How many slabs are available here? K1, K2, K3. Let us write K1, capacitance as C1, K2, capacitance as C2 and K3 capacitance as C3. Fine? Okay. Now our trick has to be used to identify C1, C2, C3 are in which combination. For that, remember the trick. K2 and K3 are parallel to the plate. So they are in series. Okay, so we have C2 and C3 in series. Fine. Okay. C1 and the combination C2-3 are perpendicular to the plate. So C2-3 and C1 will be in a parallel combination. Agreed? Such that we get C equivalent. Now using this information, let us draw a rough circuit diagram. Let us consider the two terminals as A and B and let us draw C2, C3 in series. This is C2, C3. Okay, and let us draw C1 and C2-3 combination parallel to each other. So what are we going to do? We put here a C1. So as you can see that this combination which is available to us is exactly what the diagram is saying to us. Fine. So C2, C3 are in series. C2-3's combination are in parallel to C1 from the source A, B. Potential difference. We can put a battery here. Fine. Okay. Now with this information, we can calculate C equivalent very easily. Now before that, let us write what is C1. C1, as you can see from the diagram, is K1 A upon 2 epsilon naught upon D. C2 is equal to K2 A upon 2 epsilon naught upon D upon 2. 2 cancel, so we get K2 A epsilon naught upon D. C3 is K3 A upon 2 epsilon naught upon D upon 2. 2 cancel. So K3 A epsilon naught upon D. So we are ready with C1, C2, C3. Now using this information from here, let us find out C2-3 in series combination. So which is equal to C2, C3 upon C2 plus C3, which is equal to K2 A epsilon naught upon D. multiplied by K3 A epsilon naught upon D divided by K2 A epsilon naught upon D plus K3 A epsilon naught upon D. Okay, you can use a cross symbol also. So we get A epsilon naught upon D multiplied by K2 K3 upon K2 plus K3 as C23. C23 is ready with us. Fine. Now for C equivalent, we have C1 plus C23. So let us write C1. What is C1? K1 A epsilon naught upon 2D plus C23 is A epsilon naught upon D, K2 K3 upon K2 plus K3. Taking A epsilon naught upon D as common, we have K1 upon 2 plus K2 K3 upon K2 plus K3 as the final answer for C equivalent of the combination showed to us in the diagram. Once you understand the slabs in series and the slabs in parallel, your work is nearly done. So I hope you have understood this concept. K2 and K3 are parallel to the plate, so they are in series. K1 and K2 and K3 in combined form are perpendicular to the plate. So that combination is in parallels. That's it. Then you know the formula of series and parallels. Go ahead and complete your maths. Fine. I hope you have understood very clearly. Take a pick and solve it by yourself. Such questions are asked in board also and in the entrance examinations also. Fine. Take a pick. Now here we move to the next numerical in which we have 4 dielectric slabs placed as shown. So let us understand how they are placed right now. We have 4 dielectric slabs with K1, K2, K3 and K4 with their dielectric constants. The distance D upon 2 here, D upon 2 here, A upon 2 here and A upon 2 here is given to us. Now the question is find out the equivalent capacitance of this combination. Now here the very first situation which we have to understand is what are the combinations between these slabs in series and parallels. So let us first name the capacitance with the dielectric constant K1, let it be C1, K2, let it be C2, K3, let it be C3 and K4, let it be C4. So we have four capacitors, we can say, with C1, C2, C3 and C4 as the respective capacitances as written here. Okay, now looking at the diagram and with the knowledge which we have for a series and parallel combination of dielectrics, we can consider from this portion this side and this side are parallel to each other, whereas K2 and K3 are in series with each other and K1 and K4 are in series with each other. With the same logic that Q remains the same for series combination and V remains the same for potential remains the same for parallel combination. So as discussed, C1 and C4 are in series combination. C2 and C3 are also in series combination. And then we have C14 and C23 in parallel combination. Fine? Okay? So, while deciding the combinations, we should be very careful that we get Q same for series and V same for parallel. Only then they are considered to be in series or in parallel combination. Now one more thought may come into your mind, that why not K1, K2 are in parallel combination or K4, K3 are in parallel combination, though their separation is like this. But in this case, it is not possible because their electric fields may be different and that's why their potentials also may be different, and if these potentials are different, then V is not same, and so they are not in parallel combination. Fine. So taking this information, let us draw a rough circuit for what we have done just now. As you can see, this can be written as C1, C4 in series, C2, C3 also in series, then combination C14 and C23 as written here are in parallel to each other. So C14 parallel to C23. Fine. So considering this, we can proceed by first writing what is C1. C1 is equal to K1 A upon 2 epsilon naught D upon 2, 2 cancel. So we get K1 A epsilon naught upon D. Similarly, because A2 and D2 are the dimensions of every slab here, we can write C2 is equal to K2 A epsilon naught upon D. C3 is equal to K3 A epsilon naught upon D. C4 is equal to K4 A epsilon naught upon D. So first finding out C14, which is in a series combination, we have C1, C4 upon C1 plus C4. Okay, so substituting the values from here, we get K1, K4 upon K1 plus K4, taking A epsilon naught upon D common. Simple maths, because these capacitors have A epsilon naught D. For all of them, I have taken A epsilon naught D common, where the upper numerator has the power 2 and the lower numerator has the power 1 for A epsilon naught D upon D, so I have cancelled it. Similarly, we have C23 is equal to C2, C3 upon C2 plus C3, because they are in series combination. Therefore, we have K2, K3 upon K2 plus K3. A epsilon naught upon D. Okay, so this is the simple two combinations. Now these two combinations, as I said, are in parallels to each other. So we get C equivalent is equal to C14 plus C23. So substituting the values of C14 and C23, we have A epsilon naught upon D common, as both are same. Okay, and we have in the brackets K1 K4 by K1 plus K4 plus K2 K3 upon K2 plus K3 as the equivalent capacitance for the combination shown here. Okay, this is one of the entrance question asked, and here do not get confused with the combinations given. These two are in series, these two capacitors are in series, their overall are in parallel to each other because their potentials are the same. Fine, okay. Now I shall just move, you take a pick and understand the reason for considering these combinations as they are. Fine, take a pick. Here we have a question in which it is given in the figure below X and Y represent parallel plate capacitor having the same area and the same distance of separation, means A and D are same for both of them. What is the relation between energy stored in the two capacitors? In the diagram it is also seen that the dielectric constant for X is 6 and the dielectric for the capacitor Y is air itself. So K is equal to 1 here. And here we have K is equal to 6. We can as well say epsilon R is equal to 6. Okay. So now they have already given us the values of these capacitance and we have to find out a relationship between the energy stored in the two capacitors. Fine. Okay. So now let us write down Cx, which is equal to K A epsilon naught upon D, where K is 6, so I write 6 A epsilon naught upon D. That is Cx is the capacitance of the capacitor X. Cy, the dielectric is air there, so we just write A epsilon naught upon D. Fine. Okay. So therefore we have made a relation between Cx and Cy. We can write here 6 Cy. So we have Cx is equal to 6 Cy. This is one information which we have got from the diagram. Now you can also see that both these capacitors are in series. So their charge should be same. Charge same for both of them. Fine. If the charge is same and we have the capacitance and they are asking us to find out the relationship of the energy stored, then which formula we should choose? Definitely the formula which has charge and the capacitors. Fine. Okay, so let us use its formula. U is equal to half Q square upon C. Therefore, let us use this formula for both the capacitance. We write Ux is equal to, for the capacitor X, energy stored is half Q square, Q is same for both, upon Cx. For Uy, we can write half, charge is same for both the capacitors, so I write Q square upon Cy. Now they have asked us to find out the ratio, so we can just write Ux upon Uy, which is equal to half Q square upon Cx upon half Q square upon Cy. So we can cancel half Q square. So what we get is Cy upon Cx. Fine. But what is the relation between Cy and Cx? It is Cx is equal to 6Cy. So let me substitute. Cx is equal to 6Cy here. I have substituted 6. I have substituted Cx is equal to 6Cy. So Cy cancel. I get 1 upon 6. So the ratio is Ux upon Uy, that is energy stored ratios, is equal to 1 upon 6. So that is the answer. Okay, so looking at such questions, there should be no fear. Just keep your mind within the learned formulas of the theory. It will be very easy for you to solve it. Fine. So take a pick. I'll just move. Now let us move to another type of question. On charging a parallel plate capacitor to a potential V, the spacing between the plates is halved. Okay, so spacing is halved. So first it was D, now it is D by 2. Fine. Okay, and a dielectric medium of epsilon R is equal to 10 is introduced between the plates without disconnecting the DC source. Okay, explain using expressions how capacitance, electric field and energy density. This is not energy. They are asking us about energy density of the capacitor changes. This is the question. So now first let us write that initially the capacitance of the capacitor was Ci is equal to A epsilon naught by D. Now after introduction, C of K is equal to 10. Now it is 10 A epsilon naught upon D by 2 because the distance is halved. So it becomes 20 A epsilon naught upon D. So our first bit is solved where you compare these two expressions. We get CF is equal to 20 Ci. Right? Now let us go to the second part. Second part, they are asking us to compare the electric fields. Fine? Okay. So using the formula, V is equal to ED. Therefore, E is equal to V upon D. We have EI is equal to V upon D. EF is equal to potential V remains the same. Fine, upon D upon 2. So what do we have now? We have 2V upon D. So therefore we have EF, final electric field, is equal to twice initial electric field as the comparison says. Fine. Okay. So first bit and second bit we are ready with. Only it is the game of remembrance of the formulas so that you can immediately go to the numerical. Now the third bit is asked about energy density. Fine. What is the formula for energy density? U, small u, is equal to half epsilon naught E square. Fine. E is available with us, EI and EF. So we have to just substitute there. Fine. Okay. So what do we get for UI? UI is equal to half epsilon naught EI square. UF is equal to half. Instead of epsilon naught, we will have to write K epsilon naught or epsilon R epsilon naught. EF square. Fine. Now substituting the value of epsilon R, we have UF is equal to half multiplied by epsilon r is 10. So 10 multiplied by epsilon naught. And what is EF we got just now? 2 EI. But there is a square, so we square it. Fine. Now, working out the mathematics, keeping the half as it is, 10 into 2 square becomes 40. Then I write half. Then I write epsilon naught EI square, where I can write half epsilon naught E square as UI. Fine. So finally I have UF is equal to 40 UI. Okay. So I have substituted half epsilon naught EI square as UI and got UF is equal to 40 UI. This is also one simple remembrance of the formula which we have learnt in the theory. Fine. So very important is to remember all the formulas of the theory so that the numericals can be solved very easily. Fine. So take a pic of what I have solved just now and understand what is being done. Fine.